so far we have only looked at a less than or equal to r less than or equal to b using constants a and b. But now instead, let's now have the situation of r being bound not by constants necessarily, but by functions h sub 1, h sub 2. These are going to be functions of theta. So as a picture, this is now the type of region we're trying to talk about integrating over. It might be more natural to describe this kind of shape using polar coordinates instead of rectangular coordinates. So you might have, still we're going to have theta going between two constants alpha and beta. So you might have, that might be theta is equal to alpha. You might have something like this, theta is equal to beta here. And so you only want the space that's in between. But instead of being stuck, instead of having r only stuck between two constant values so that the only shape we can have are basically pizza crust pieces, now something perhaps more interesting can happen, and the value of r may vary dependent on what angle you're at. So we might have a region that looks something like this, and we'll call that capital D. Right? And so this part right here is meant to, if we were to continue this curve, this is, r is being given by plugging in theta into some function called h sub 1, and over here the value of r is being given by plugging in theta into another function called h sub 2. So if you have a region D that is described this way as the set of all points described in polar coordinates, where theta is stuck between two constants alpha and beta, and r is given by values between two functions of theta, so h sub 1 of theta, h sub 2 of theta, then we can describe the double integral over this region D of f of x comma y dA to convert this just from, you might have a function presented using x's and y's, but to write this in polar coordinates, we would have so the dA would, as usual, convert to r dr d theta. Your theta values would go from, well, as we see here, alpha to beta. We have our r values being now given by the functions h sub 1 and h sub 2. So h sub 1 of theta, h sub 2 of theta, and then f of x comma y, well, every x needs to get replaced with r cosine theta, and every y here needs to get replaced with r sine theta. Okay, so I know when we start looking at an example, this will be clearer, but I think I'd like to point out here that this is the book's way of talking about how you should replace every x with r cosine theta. Same general comment for the r sine theta here. I just don't really have room to write about it. And then finally, in this part right there, still just as friendly reminder, please don't forget the r that appears right here in r dr d theta is equal to dA.